Hello dear students, in previous lesson we have learned what modules are in JDK. We also created our first modular application. In case you skipped previous lesson, please make sure you watched it. Because in this lesson we'll keep talking about modules. But this time we'll not create our modular application from scratch, but instead we'll focus our attention on the questions of migration of non-modular Java application to modular Java application. Also, this lesson will be interesting for architects who are in charge of Java migration and responsible for making decisions and planning next migration steps. You need to be aware about issues and solutions that we are going to discuss in this lesson. This is a super important topic, especially if your organization made a decision to migrate from Java 8 to another long-term support version, like Java 11. That includes support of modules. And also, this is super important in case you decide to pass Oracle Java certifications, because some of the Oracle certifications include questions about migration to modular application, including top-down and bottom-up migration, and splitting a Java SE 8 application into modules for migration. And I'd like to pass the mic to my artificial intelligence, who will help me with creation of voice for this lesson with native American accent, following my script, in order you could understand me better.
We will start our lesson from learning and understand of the general algorithm for migration of our code to the new environment, including migration to the newer version of JDK. Special focus today we will pay to migration of application to modular architecture. I will explain you what Java Class Dependency Analyzer tool is, and what Java Deprecated API Scanner tool is. Also, we are going to learn today different migration strategies. We will review bottom-up and top-down migration strategies. Let's start our lesson. And before start diving in details, let's come up with steps and migration algorithm first. The step number 0 and super important one. If you would read internet, not sure that you would find this advice anywhere. But exactly this advice helped me to migrate billion worth software products to different versions and environments. Before any movements with code that potentially may impact the way how program works, no matter whether this is refactoring or migrating, anything what may impact or change code and the way how it is executed, make sure that you have reliable suite of tests on different levels. The general recommendation there would be to automate as much as possible. Some of my clients saying me that test automation is a huge investment and they have dedicated manual regression team. And cost-wise it is easy to understand their point if we are talking about short period of time and relatively not complex project. But I also saw projects where regression takes months. Nowadays probably it is crazy amount of time that wouldn't let this software product to survive in the current environment, where your competitors releasing new features each week or 2 weeks and your product only has regression for 1 month. Definitely, there are different areas and domains, some of them more competitive, some of them less, but I'm sure you understood my point. So when my clients saying me about not having enough resources on the creation of automation testing framework, that includes smoke test suites, regression test suites, etc., I'm asking simple question, are you sure that in this case you have enough resources and needs to hold any migrations? Probably, it is better to put resources into product development, marketing to win market, find investments and come to the point where we have enough resources to scale and grow. Because otherwise, we are not doing any migration just to do migration. We need to identify purposes of the migration and be sure that our migration brings some value and it is needed. And if it is needed, we are happy to accept all impacts and provide everything what is necessary to make this happen. Here is where the first principle comes from. We need to identify goal of our migration and measure those to stay specific and objective. What we are trying to achieve. Better performance, better security, better code design in order to be able to scale application faster. This is super important. And once goal is defined, make measurements of the current system. You need to have something in order you could say that migration has been successful after migration and that goals were achieved. Because at the end of the day, we never do refactoring or migration just for fun. We do it to get advantage of measurable benefits. Never forget about this. Let's agree that in scope of this particular demo we will hold migration to another long-term support Java release, in order to achieve better code structure in order to simplify introducing of new features. Improving code architecture to make each release predictable and reduce impact of introducing new changes on already released code. Improve security via achieving better encapsulation of components. Greater platform integrity. Improved performance. These are goals of Java Platform Modular System. And in case you missed previous lesson, please watch it, because we discussed goals and benefits of modules in details in previous lesson. And if we agreed to migrate our app to the modular architecture, let's review the following steps for this. The next thing that we need to do is to download the updated JDK version. Java Platform Modular System finally was introduced in Java version 9. But, as we discussed in the first lesson about JDK, I would recommend you to use long-term support Java versions. Nowadays we have two LTS versions, they are 8 and 11. Considering that we want to migrate our app to have modular application, most likely we would opt with Java version 11. But you also can opt for Java version 9 if you wish. Run application with new JDK. This is also important step. Java ensures backward compatibility, but still, there might be some changes. For example, if you use some options for garbage collector, pay attention that, for example, in JDK 12, some of them were removed. That's why, even despite Java guarantees backward compatibility, it is never redundant to compile and run your app with newer JDK version. Also, this might be important to ensure compatibility with the third-party libraries. So the main goal is to run your app on the newest JDK version. And to deal with this task you need to be aware about new features in Java release that you want to use for migration. This can be easily found on the official websites. The fourth step would be to update third-party dependencies if needed. So, we need to make sure that your app with all external dependencies may be compiled, built and started successfully. Run jdeps against your project. In case you are not familiar with jdeps and don't know what it is, let me quickly explain. Basically, this is tool that is present in JDK to identify dependencies between classes, modules, packages in your app. It is a command line tool to run the Java Class Dependency Analyzer tool. It processes Java bytecode, meaning class files are the jars that contain them, and analyzes the statically declared dependencies between classes. The results can be filtered in various ways and can be aggregated to package or jar level. jdeps is also fully aware of the module system. This is super important and useful for you to understand before you plan any migration and before you made final decision about your modules and packages structure. A little bit later in this lesson I'm going to show you how to work with jdeps program. Run jreprscan against your project. If you are not familiar with this tool, let me quickly explain what it is. This tool is a static analysis tool that scans a jar file, or some other aggregation of class files, for usages of deprecated API elements. When you upgrade to the newer JDK version, you might be interested in this information too, to update your code accordingly to not accumulate dependencies on deprecated classes and methods. A little bit later today on real example I'm going to show you how to apply this tool. Now, after all these steps, we are safe to proceed with the next steps. On this stage, having all necessary input information, we are ready to make decisions and plan migration. We need to select migration strategy. Today we will discuss few of them. Once you selected migration strategy and plan migration steps, we are good to proceed with migration execution. Usually, Oracle and community release migration guides for each new version that contains important information that you need to consider during the migration of your app. One of such guides I will leave in attachments to the lesson, but you can easily find similar guides for other versions. And each migration should be followed by regression testing. We already discussed that even before starting doing steps like this we need to make sure that we have reliable suite of tests that will allow us to confirm that at least nothing is broken and migration goals are achieved. After that, we are ready to proceed with the step where you can apply measurements that you did before migration to verify reaching of migration goals. For example, if the goal was to improve performance, measure performance of your app after migration. And if performance become even worse, the question is whether migration was successful? I don't think so. That means that some steps still need to be done and plan of migration should be adjusted to include additional steps to reach the goal of migration. Does it make sense? So, now I'd like you to review the algorithm one more time. Press pause if needed. And once you're sure about each step in this sequence of actions, we are good to proceed. The step number 0, I have separate course for that. You can check my course regarding test-driven development, I elaborated a lot on this topic. Step number 1 is up to you and your organization. You should identify goals of migration internally, and I wouldn't be able to help you with that. Do not forget to perform any measurements along with each goal to compare these before migration and after migration. Regarding downloading of the latest JDK version, I believe if you are already watching this lesson you are smart, and mature enough to download Oracle JDK or OpenJDK. After that, you need to run your project with new JDK. I'm sure you will be able to do that one too. The same as updating third-party dependencies too. And with the next step, probably, let me help you with that one. Let me explain you more about jdeps program, how to use it, and show this on live demo. So, as we've discussed, jdeps is a Java dependency analysis tool. Probably the first question that students ask me is where they can get jdeps and what they should download. I want to say that you don't need to worry about that. If you have JDK downloaded on your PC, this program is already there, waiting for you in bin folder since Java version 8. We will work with this tool directly from command prompt. So make sure that your JDK path configured properly and that jdeps version command returns you result in command line. Let me show you a quick demo in order you could understand how to work with this tool. This tool may analyze group of classes. Let me show you two examples now. In the first example, I will show you how to analyze old-fashioned plain Java project. As a sample project, we are going to use my Java project with examples. The one that I use to demonstrate different topics to students of mine. And in the second example, we will analyze more simple modular project that doesn't have too much dependencies between different packages and modules. In case you have Java project, the first thing that you need to do is to aggregate all compiled resources in one folder, desirably jar archive. In separate lessons, we will learn such build tools as Ant, Maven, Gradle, etc. That tools are in charge of building your project, creating some deployable pieces, like jars or wars. In our specific case, we need to generate jar by ourselves. In Eclipse, I can easily do this by mouse right click on the project, finding export option, and selecting jar file from the options here. Now we need to specify jar path and place where archive will be located and generated. There are numerous of other options. Majority of them are self-describing. I wouldn't stop on those, but even in case you have some questions, let me know in comments below this video and I will be happy to answer. Now, when we have jar file, we are ready to analyze it. I open git bash terminal in this folder and I will execute my script in this directory. Command that I'm going to execute is stored in jdeps.command.sh file. I store this script under the git index so that you could investigate it later. Let me open this script and I will explain you what is written here. jdeps, this is actually to invoke Java dependency analysis. .output is a command line option to specify a destination directory for .file output. .file content is simple text that can be copied and pasted into the online editor, for example, or other editors, to generate a graph that visualize dependencies. We will generate one in a minute. You can see that I use dot after .output option. If you are familiar with this character, then you already know that dot refers to the current directory. So this means that dot file will be generated in the current directory, where this command will be executed. The next option is recursive. This option recursively traverses all runtime dependencies. Class path option specifies directory with class path, including external dependencies. In our particular cases, we had few external dependencies on different lessons and I downloaded these jars into my downloads folder. That's why I also included those here. And the last program argument is jar to analyze. Basically, that is the one that we built. It contains all classes from all packages of my training project. Let's execute this script. I wrote the name of the script to console. And press enter. It takes some time to analyze dependencies, but finally, .file is generated in the current directory. Let's open it. And you can see that content of this file is just text that contains some specific structure. You can see dependency of each package on another package. Probably, when you have such amount of packages, it is even better to use this text representation to analyze this data and think about structuring new modules. But still, if you want to visualize it, let's use special tool for that. We can find online tool to visualize our dependencies. For example, we can use just one of such tools. I'm talking about WebGraphviz. Just copy and paste content of .file, paste here, and press generate graph button. That was easy. But you can see how much cross dependencies we have. Definitely there is a lot of work here. Considering this is learning project and a lot of different topics, some of them very often reuses some common classes or packages. And that's why we have something like this. You can spend time after the lesson investigating this. I added these files into git index, so you will be able to find those in the root directory of the project. Most likely, if you would migrate old project that doesn't have modular structure, you would see something like this, or even worse. Well, most likely you will see worse. Sorry, but this is true. Okay, let's move on. And now I'd like to show you how to work with this tool if you would like to analyze modular application. And you remember that on previous lesson we created modular application. Let's analyze dependencies for the app that we created in previous lesson. The idea is the similar, but instead of jar you can pass the reference to the directory with your modules. So, you already can make a conclusion, that jdeps program has separate group of command line options for modular and non-modular applications. The command line that I want to execute is also stored in shell script. Let me open this file and we will discuss what is written here. Also, to execute shell script in other directory, I open terminal. As you can see, I use module path command line option and pass the reference to the directory where all my modules located. Another option is add modules to the root set for analysis. I use constant to add all modules in the directory. And the last option here in the list is pretty familiar to you. This is for .output. Let's execute this script in the terminal. And we have generated summary file. Let's copy content from here, and let me paste this content on the website to generate graph. As you can see, com, IT bulls, app, depends on com, IT bulls, greetings, module, and both of them depends on Java base module. Is that clear for you? Press a pause for a minute and think one more time about this live demo. In case something is still not clear for you, please do not hesitate to put your question below this video and I will be happy to answer. On the screen you can find command line options that you may use with jdeps. On the slide you can find possible options. Module dependency analysis options. Options to filter dependencies. Options to filter classes to be analyzed. And as you can see there are a lot of them. Probably, it doesn't make any sense me holding demo of each option. I believe you understood the main principle and saw live demo with few options. You can just play with other options if you want. Feel free to pause the video if you want to read all comments on the slide. Okay, let's proceed. The next thing that I'm going to demo you is jreprscan program. Java Deprecated API Scanner tool is a command line tool to scan for uses of deprecated API elements of given Java class files. Input classes can be given as a path name to a class file, a directory, or a jar file. The same as jdeps, jreprscan also has been included in JDK installation since JDK 8. That means you can find it in bin folder of JDK. And if you configure Java path properly, you can access it from command line. I'm going to show you example with scanning of my learning project. I put jreprscan in shell script. The simplest way how to use this command is to invoke it and pass jar name that we would like to scan. I want to execute this script in git bash. And again, it takes some time, because project has a lot of files. And it is done. On the top you can see notifications, in which classes I use deprecated methods. Knowing this information, you can just check deprecated methods. Usually, in documentation to the deprecated method it is specified, which other method you should use instead. That is simple. Agree? And this command also has few important command line options. Definitely, there are less of them that jdeps program has, but still, something for you at least to be aware of. Press pause if you want to explore all of these in details. And if you are okay, I will continue. Now, let's review migration strategies. We will cover case when original application is based on Java version that is less than Java 9, or it is Java 9 or higher but modular approach was not originally implemented, since the use of this mechanism is fully optional. We already learned tools and went through the step where we determine which modules, jar files are present in an application and what dependencies exist between them. Also another way to do that besides such automatic tools of static code analysis as jdeps is through a hierarchical diagram where these dependencies are represented in a layered way. This will help give an overview of the components of the application and of which of them and in which order they can be migrated, identifying those who will not be able to adapt temporarily or definitively. The latter case can be given for example in third parties libraries that have stopped offering support and that will hardly become modules. There are two different migration mechanisms that respond to different initial situations. To illustrate the process in each of them, let's imagine the next scenario. We plan to migrate an application that consists of 3 jars, representing the different layers of the application. They are application, services, and utils. The diagram that you can see on the screen now shows the dependencies between these layers where application depends on services and utils, and services depends on utils only. Let's review bottom-up migration first. In this strategy initially all jar files that are part of the application will be located at its class path. Then, all of them can be migrated one by one to the module path. To do this, we need to follow described steps. The first thing that we need to do is to choose the project, package, or layer with the lowest position in dependencies hierarchy that has not yet been migrated to module. That means to select the project that has less dependencies. In our case, this is utils layer. After that, add the module info Java file to the project. It will be needed to add the required export statements to make current module packages available to hierarchy higher level modules. Move the migrated project as a named module from applications class path to its module path. Ensure that all not yet migrated modules remain as unnamed modules in applications class path. What is unnamed modules? We discussed on previous lesson when we learned modules types. Please refer to the previous lesson to review that if needed. After we did all this, the only thing that remains to do is to repeat this process with the next lowest level packages, layers or projects in the hierarchy that is not migrated yet. And we are progressing in the bottom-up direction. Can you understand now why this strategy is called bottom-up? When this approach works the best? And when we need to apply it? The bottom-up migration strategy works best when we have the ability to modify any jar that has not yet been converted to module. It makes easier the migration of the projects, packages or the whole layers that are at the top of the dependency diagram, and encourages care in what is exposed to other modules. The modules of the lower levels of the hierarchy will be found in the module path without access to the packages of unnamed modules, while these unnamed modules that have not yet been migrated and are located in the class path will be able to access the packages located in both class path and module path. Does it make sense so far? Another migration strategy would be top-down. In this strategy, initially all jar files that are part of the application will be located at its module path, so all non-migrated projects are treated as automatic modules. In previous lesson I covered what automatic modules are, so please, make sure you watched previous lesson about modules if you forget. This is example when I didn't use modular approach since it is optional. In this case it is recommended to follow the next steps. The first thing to do is to choose the higher level project in the dependencies hierarchy that has not yet been migrated to module. After that, we need to add the module info Java file to the project to transform it from an automatic module to a named module. Also, we shouldn't forget to add necessary export statements to make current module packages available to other modules, and the necessary require statements that makes available other modules exposed packages to the current one. In case of reference to a module not yet migrated, it should be done through its automatic module name. When these have been migrated, these references should be changed to their definitive module names. Repeat this process with the next higher level component in the hierarchy that is not migrated yet. Do you understand in which cases top-down strategy needs to be applied and works the best? This strategy works best when you do not have the possibility of modularizing all the dependencies of the application, whether temporary or definitively. Although the lower dependencies of the application have not yet been modularized, the application itself can be converted into a module. Named modules that have already been migrated will be found in the module path with access to the entire code contained in the automatic modules that are also found in module path. Is that clear? And remember another important thing, in all cases we have to avoid circular dependencies between modules. That's all what I wanted to share with you in this lesson. Let's recap what we've learned today. After this lesson, you know general algorithm to follow during the platform migration to the new environment, or another JDK version in particular. I showed you how to use on practice Java Class Dependency Analyzer tool. Also, we reviewed how to use Java Deprecated API Scanner tool. We reviewed different migration strategies. Namely, we learned bottom-up and top-down migration strategies. I hope you loved this lesson and learned a lot of new and useful things. Thanks a lot for your attention. Have a great day and see you in the next lesson.